Hello, we're going to look at a Pythagorean theorem example using related rates. I'm not going to tell you it's Pythagorean theorem, you're going to have to realize that on your own. But it does pop up, so consider it as you draw the picture that Pythagorean theorem is very likely. Not always, though. So here we go. Two cars start moving from the same point. One's traveling south at 50 miles per hour and the other west at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So what we need to do, I highly recommend drawing a picture, okay? And so I got a starting point. I got car 1 heading south. I got car 2, so we'll call this guy car 1. And this guy car 2. So car 1's heading south, car 2 heading west. Okay? And so hopefully you can see that the location of the cars, how far apart they are, is the hypotenuse of this right triangle. And so we have ourselves a right angle. So hopefully you can see that. Now we need some variables. You can use whatever variables you like. They didn't really give any indication of what you should use. So let's call x car 1 and y car 2. And z the distance between them. You can call them whatever you want though. So let's label it just so we understand. So x is going to go with car 1's distance. Y goes with car 2's distance, and Z is the distance between car 1 and car 2. So if you notice, I have a relationship between three sides of a triangle, not any indication on the angles. And so we're going to use Pythagorean theorem. Hopefully that at this point it should be clicking. We still probably want to write down some better information. Let's kind of dissect the question that's being asked. So they say, at what rate is the distance between the cars increasing? So our job is to find the change in z over time, change in z, so the distance apart. So dz over dt when time is 2 hours. Okay? So a little bit of a difficult question here. So I'm going to kind of start doing some of the work on another sheet here. So kind of keeping this idea in mind, we're going to go into Pythagorean theorem. Maybe I can kind of do it like this. There we go. So the relationship between the three sides, x squared plus y squared equals z squared. Hopefully you're familiar with that. And then we're going to differentiate. So 2x dx over dt plus 2y dy over dt equals 2z dz over dt. And so what we're hoping when you do a related rates problem is that you were able to come up with your own equation based upon the situation, take the derivative, plug in the information you know, and hopefully everything's taken care of. But if you notice here, we know this, we know dx over dt. Okay, they told me that car 1 is moving south at 50 miles per hour. That is dx over dt. So I know that's 50. I know car 2's rate is 25. So he's dy over dt. But what I'm not familiar with that really seems like a problem is X, Y, and Z. That is a problem. okay? And so we need to pay attention on what we're going to do here. Just because you have these issues doesn't mean you've done something wrong. It means that you probably need to pay attention to the situation that's currently happening, okay, in order to get these values. Okay, because remember, dz is what we're trying to find. So what we really want to have is just dz over dt hanging out by itself, everything else just numbers, and we're fine. So let's think about this situation again, okay? We have ourselves a right triangle, okay? And we know something. We know that car 1 has traveled 2 hours at 50 miles per hour. So 2 times 50, this is 100. So at 2 hours, we know the distance that car has traveled. Likewise, we know that car Y has traveled 2 hours at 25 miles per hour, which means it's traveled at the moment we're interested in 50 miles. And so I know these two values, and then hopefully I can do Pythagorean theorem to figure out the third, okay? And so I'm just going to go quickly use my calculator. So square root of 50 squared plus 100 squared. You should know how to do Pythagorean theorem here in calculus. And here we're going to get 111.8. Okay, so that's the distance these cars are apart. They're 111.8 miles away after 2 hours of driving. So what we're going to do is now I have information I can plug into my my differentiated equation here. I now know that information. So I know 2 times x, this is the value of x at 2 hours, times the rate, plus 2y. We know what y is at that point, and we know its rate, equals 2z. We know z at this point. The only thing we don't know is how is that rate between the two cars changing. Okay, how's the distance between those two cars changing? And so look, I have all these numbers and one unknown. That's exactly what we want to have. So from here, obviously you probably don't need to show much work. I'm just going to go quickly with my calculator. And in doing that, I'm going to wind up getting 55.9 miles per hour is the change at that moment of 2 hours. Okay. Challenging. You got to try these on your own. Let me know if you need any help. You're going to see a few of these questions in your assignment. Look for later videos. I'll try to go back to the Pythagorean theorem because it just shows up a lot. Okay.